Hello friends, today we are going to take our next topic of our fourth unit, industrial production, estimation and utilization of our phytoconstituent caffeine. So today we are going to take on caffeine. Caffeine, let's take a cup of tea together. So you have seen, you have heard this these linings many times in your daily life. So caffeine is isolated from most of you must be knowing that caffeine is present in your tea, in your coffee. So yes, caffeine is isolated from the tea which you drink, the coffee which you take. Caffeine is a methyl xanthine. Chemically, if you look at the structure, it's a methyl xanthine, and it is isolated from two sources. So because two sources, like you can isolate it from the leaves of your tea which you drink daily. It can be isolated from the Thea sinensis leaves, which belongs to the family Theaceae, and the beans of coffee arabica, which belongs to the family Rubiaceae. So you have two sources for your caffeine. You can either use tea leaves, or you can either use coffee beans, but because the caffeine is present in tea leaves in excellent amount, which can be isolated on commercial scale. So we utilize tea leaves for commercial isolation of caffeine. It's a white crystalline powder, and it is categorized into the group of pseudoalkaloids. They are moderately soluble in alcohol and cold water, but it is soluble in hot water. So if you want to prepare cold tea, then you have to first boil the tea into the water, and then you have to cool down the extract. So because because caffeine is soluble in hot water only, it is insoluble in cold water. As far as the distribution of tea and coffee is concerned, you can see that tea is widely distributed to the temperate Asian region, and especially Assam and Darjeeling teas. They are geographical indications. Geographical indications means they are proprietary locations where you can cultivate the, or you can grow the Assam or Darjeeling teas. So as far as the source for coffee is concerned, which is the second source for isolation of caffeine, you can obtain the coffee from India also, but it is grown in coffee beans. They are coffee trees. They are grown in tropical climates. Like in India, we have Tamil Nadu, we have Sri Lanka also, where we have got excellent quality coffee beans. So this is the source of caffeine, or the parent drug from which the caffeine is isolated. If we move on to the cultivation process and processing of tea, you can see there are tea leaves. These are the fresh tea leaves from which we isolate caffeine. These are the dried tea leaves, and these are the coffee beans, and this is the structure of caffeine, or you can say this is the caffeine needle caffeine needles, or the needle like powder of your caffeine. It is the structure of caffeine. You must have heard that there are various kind of tea available in the market. There are green teas, there are black teas, blah blah, there are many kind of teas. So on the how you will differentiate the type of teas? So the name was given due to their processing technique. If you can see, these are the fresh tea leaves. They are withered. Withered means they are rolled on one another. They are mashed up. Withering means they are mashed up. Okay, after mash up or after withering, if you steam or pan fry the leaves, and after that you will roll down and then dry, you will get the green tea. So this is the technique through which green tea was prepared. If you want to prepare the oblong tea, then you have to treat the withered leaf. You have to shake them, you have to ferment them. Partial fermentation is involved in case of oblong tea. After partial fermentation, you have to pan fry the leaves and then dry, and this will gives you the oolong tea. Then the withered tree, when they are rolled and then full fermentation is involved, and then dried, you can get the black tea. So these are the various techniques or various processes through which you can obtain your tea leaves, your different kinds of tea. In case of white tea, if you want to have white tea, then you can steam the fresh leaves. You can steam the fresh leaves, they are steamed and then dried, and after that you can get the white tea. So these are the various kinds of tea which are available in the market. So if we want to isolate the caffeine from tea leaves, we have to use the green leaves. Use the green leaves for isolation of, or you can say it, source for caffeine. Okay, we are going to use green leaves for as a source for caffeine. Because here we are concerned about the individual phytoconstituent caffeine, so we should know how this caffeine is going to act in our body. So mechanism of action, if you look at the mechanism of action of caffeine, when you work, you get exhausted, and after when you work and you get exhausted, there is a secretion of adenosine in the brain. Adenosine in the brain, these are the neurotransmitters which are released into the body when you are in stress or when you are overworked. So the primary mechanism of caffeine action is antagonism of this adenosine on the adenosine receptor. So normally what happens, caffeine blocks the adenosine receptors. With its own molecule, preventing the adenosine molecule binding to the adenosine receptor. The brain activity remains at its excited state and can even increase in activity because adenosine is unable to slow it down. So what happens, caffeine, it inhibits the attachment of, or it antagonizes the attachment of adenosine onto the adenosine receptor, and when adenosine receptor was blocked, its activity was blocked. And what was its activity? Its activity is to make you relax. Adenosine is to make you relax. The activation of adenosine receptor is to make you relax. But when caffeine binds to the adenosine receptor, it won't allow to adenosine to bind to the adenosine receptor. So adenosine receptor is not get activated and the relaxation is not generally achieved. Your body remains in active state or in the excited state as previous. So this is the mechanism of action with which caffeine act on your body. There is a simple process for production of caffeine from tea leaves. You took the dried tea leaves, which generally we got from the market. We got the chai patti in the packets. We use these dried leaves. We mix the dried leaves with calcium carbonate and we add the water, and we boil the mixture of water, calcium carbonate and dried leaves for around 40 minutes. And this the purpose of this boiling is to make the tannins which are available in the tea leaves along with the caffeine into a water soluble salt. So this mixture is then after 40 minutes of boiling, it is then filtered using muslin cloths while hot. We have seen that caffeine is soluble only in hot water. So it is very important that we filter the mixture when it is hot, and the mixture is then transferred to the separating funnel. In the separating funnel, the mixture is washed with chloroform thrice, or you can use any other organic solvent like you can use ethyl acetate also. So we have used here chloroform for washing of the above filtrate. It is washed with chloroform. The chloroform, which is generally the lower layer separated in the separating funnel, it is then collected and to this this chloroform extract, because in this chloroform extract we have our color pigments also. Chlorophyll is also soluble in chloroform. So, to remove of all these coloring pigments, we have used activated charcoal, and after using the activated charcoal, this activated charcoal will absorb all the coloring pigments which are present in the filtrate. So, and the mixture is then filtered. So, what happen, you will get a colorless filtrate out of this. This colorless filtrate is then evaporated to dryness, and as soon as the solvent dries, you can see the white flakes or white crystals of crude caffeine, they form on the bottom of your petri plate or your china dish in which you are evaporating the solvent. After this, you can purify the crude caffeine you have obtained from this method. You can purify this crude caffeine using sublimation. The pure caffeine crystalline, the pure caffeine crystals or the white powder, white powder either in the form of needle or colorless, or in the shape of or in the form of colorless needle like crystals. So, in this way, this is a simple method through which you can you can separate your caffeine from the tea leaves. Since we have isolated the caffeine from the tea leaves, and here we have to confirm the identity of the isolated phytoconstituent. So, here we have a specialized test for caffeine, and this test is especially designed for purine alkaloids. So, since caffeine belongs to the purine alkaloid class, so we have this test, Murex test we call it. Here we took the sample, we add some drops of concentrated HCl to the sample and traces of potassium chlorate. This mixture is evaporated on water bath. After evaporation of this mixture on water bath, you will have some remains of red color produced on the petri plate or the china dish, which upon addition of ammonia turns into violet, and this is the confirmative test for caffeine. If your sample contains caffeine, then you will get the red color after evaporation of the mixture, and upon addition of ammonia you will get the violet color, and it confirms the presence of purine alkaloid in your sample. So, this is the separating funnel we have utilized for various separation tasks we have performed in the production techniques. Here what happens, the two immiscible liquid, they get separated from one another, on naturally they get separated, but if we want to partition a solvent from one solvent system to solute, if we want to partition a solute from one solvent system to another, then we can also use this technique where the solute get partitioned into the respective solvent, or from one solvent to another solvent on the basis of its solubility or on the basis of its partition coefficient. This is the rotary vacuum evaporator, one of the most important technique. We have already discussed in our previous lectures also. What happens, you apply the heat source here. After application of heat, this is the rotating round bottom flask. This rotating round bottom flask, this makes the uniform distribution of heat throughout your round bottom flask or throughout the filter, throughout your filtrate which is put into the which is put into the round bottom flask. So, what happen, as it rotates, there forms a fine layer of solvent, and fine layer of solvent, it gets evaporated, and the fine molecules from this fine layer of solvent, the molecules of your solvent, they gets evaporated. Simultaneously, we have also applied the vacuum. There is a mechanism of vacuum through this tube, and due to the vacuum our solvent vaporizes at a very low temperature, and due to this evaporation our phytoconstituent which might be thermolabile. So, this technique is very useful for those compounds which are thermally unstable or thermolabile, they get degraded by high temperature. So what happen here, our phytoconstant it get preserved, because the solvent it is getting evaporated at a very low temperature. Suppose a solvent which evaporate at 100 degree temperature or 100 to 120 degree temperature, here after utilizing this rotary vacuum evaporator, our solvent it get evaporated at a very low temperature of around 60 to 70 or up to 80, in case if you are having your solvent boiling temperature 120 degrees Celsius. So in this way your vapors they enter this condenser, and these vapors they attach to the condenser tube and they get condensed in the form of drops, and these drops of solvents they are collected into the round bottom flask, or you can say it collector. So this solvent which is collected in this round bottom flask, it can be utilized again and again. The only thing you have to do is to check the presence of any phytoconstant in this solvent. So this the benefits of this rotary vacuum evaporator is, first thing, you get the protection of your phytochemical, and recovery of solvent. So two achievements we have made here using rotary vacuum evaporator. We have got our solvent which is generally lost during open evaporation on water bath. So here we have preserved our thermolabile phytoconstant, as well as we have recovered our solvent for further use or for recycling also. If we look at the properties of caffeine, we have isolated caffeine, we have tested its identity using Murex test in the previous slides. Here we have some physical properties we have to we should know about the caffeine. The boiling point of caffeine is around 178 degree Celsius. Caffeine boils at 178 degree Celsius, and it has got a melting point of 235 degree Celsius. There is an exception that sometimes what happen at reduced pressure, our caffeine it gets sublimation, it gets sublimized, it directly converted into the from the solid state, it directly converted into the gaseous state. So it has got water solubility, it has a moderate water solubility, it is soluble in water, ethanol and chloroform, but it is insoluble or moderately soluble in cold water. It has got a density of 1.23 grams per ml. It has got a storage temperature of about 15 to 30 degrees Celsius, and this is quite possible temperature. You can manage this temperature. In the purified form, you can these crystals, these caffeine crystals can be stored at a temperature of 15 to 30 degree Celsius temperature. Then this powder can be stored in your open also, or in the refrigerator also. Color we have seen in the pictures also. It's a white to off-white crystalline white color solid. Its solubility, if you see the solubility as temperature increases, 1 gram of caffeine it dissolves in 46 ml of water, 46 ml of cold water, water at room temperature. Only 1 gram of your caffeine dissolves in 46 ml of water. But as you increase the temperature, to 80 degrees Celsius, the solubility of caffeine increases in water. Then 5.5 ml 1 gram of your caffeine, it can be dissolved in 5.5 ml of water at 80 degrees Celsius, and 1 gram of caffeine can be dissolved in 1.5 ml of boiling water when the temperature achieves the boiling stage. Lambda max, here we have two lambda maxes. 205 nanometer and 275 nanometer. Lambda max means the UV absorption wavelength at which your compound, your phytochemical shows maximum absorbance. Moving on to the next slide, or the estimation part of caffeine, you can see that we have several techniques like thin layer chromatography, high pressure liquid chromatography, high performance thin layer chromatography, for which we can utilize for estimation of our phytoconstituent in our sample. So here if you look at the TLC, we have used the silica gel, we have used the silica gel plates, pre-coated silica gel plates. Mobile phase for TLC we have used is ethyl acetate, methanol and ammonium hydroxide in the ratio of 8.5, 1 and 0.5 ml volume to volume. Means ethyl acetate 8.5 ml, 1 ml of methanol and 0.5 ml of ammonium hydroxide. Under these conditions you can get the RF value, retention factor value of caffeine at 0.64 RF value. Here we have detected our phytoconstituent caffeine on the TLC chromatogram by spraying with the ferric chloride reagent, ferric chloride with iodine. This reagent is sprayed onto the developed plate and caffeine is detected at an RF value of 0.64. The sample for this analysis we have prepared by dissolving 1 mg of your drug, and probably drug is your tea leaves or the tablets or something that contains caffeine. It is dissolved in 10 ml of methanol, and the standard here we have prepared by dissolving 1 mg of caffeine, standard caffeine we have used, and it is dissolved in 1 ml of methanol, and the sample they are spotted on the TLC plate, and we have achieved the separation, and we have detected the spot at an RF value of 0.64 nanometer, 0.64. If we look at the HPLC column, we have used the Zorbex Eclipse. Zorbex Eclipse is the brand name, and C18 column we used, C18 column octadecyl silane. C18 column is a column, it is a column which is packed with silica gel, and these silica gels they are coated with a polymer containing 18 carbon atoms. This polymer chain contains 18 carbon atom, and there is a pore size it is around 5 micrometer. So only a particle which is less than 5 micrometer it can pass through this column. For large particles like that of protein, we use the columns with the large pore size. So the mobile phase for HPLC analysis we have used acetonitrile and deionized water in the ratio of 95:5. We have performed the isocratic elution. Isocratic elution means we have utilized the same mobile phase throughout the separation. We have used the acetonitrile and deionized water combination in the ratio of 95:5 throughout our elution time. The flow rate in the column was maintained at 0.9 ml per minute, and the injection volume which we have injected in the HPLC column is 5 microliter. In the previous lectures we have seen that we have injected 20 microliters of injection in the HPLC machine. We have set our UV detector of HPLC machine at 273 nanometer. Since our compound detects we have seen the lambda max of caffeine at 275 nanometer. So we have set our HPLC detector at 273 nanometer, where we can easily detect our compound. The retention time at which the caffeine was detected is about 1.75 minutes. The sample for HPLC analysis we have prepared by dissolving 1 mg of our drug, in which we have to identify the caffeine, in 10 ml of methanol, and similarly the standard caffeine was dissolved in 1 ml of mobile phase. 1 mg of caffeine was dissolved in 1 ml of mobile phase, and the sample was injected into the column. The HPTLC analysis of caffeine, if we look, as the HPTLC analysis, we can see that we have used the pre-coated silica gel plates. 60F254 nanometer is the specifications for TLC plate. We have utilized nitrogen gas for application of sample. The mobile phase for HPTLC analysis, we have used chloroform and methanol in the ratio of 25:1, and it is important here that caffeine is soluble in both chloroform and methanol, and more solubility is in chloroform. So, here that is why we have used the mobile phases, chloroform and methanol. TLC chamber was saturated for about 10 minutes. The total run time for the HPLC analysis is about 25 minutes at room temperature 27 plus minus 2 degrees Celsius. Mobile phase run distance is about 8 centimeter from the site of application. It means that if you applied the sample here, it runs around 8 centimeter. The solvent system, it runs up to 8 centimeter and your compound gets separated here. So, 80 millimeter or 8 centimeter is the your mobile phase run distance. Derivatizing reagent, here we have used anisaldehyde sulfuric acid reagent and TLC is dried in hot air oven at 105 degrees Celsius. UV maximum, here we also set for HPTLC analysis, we set the scanners, UV scanners we have set at 275 nanometers, and we have achieved an RF value of 0.24. We have achieved a RF value of 0.24 in the in our chromatogram. Here we have prepared the sample by dissolving 1 mg of drug in 10 ml of dichloromethane, and standard we have prepared by dissolving 1 mg of our caffeine in 1 ml of methanol. So, this is the technique we can use for estimation or analysis of our phytoconstituent caffeine or any phytoconstituent in our drug sample. If you look at the HPTLC analysis, you can see the sulfuric acid, anisaldehyde sulfuric acid reagent we have sprayed. We have to spray the reagent. Normally these separated compounds, they might not be visible, but when we derivatize them, they might form colored. Here they are not visible. They are separated, but they are not visible. But after derivatization, they can be colored. They can form color. So, in this way, you can detect your caffeine in HPTLC. Utilization part, if you see, caffeine helps to ward off the Alzheimer's, and it also increases memory. So, you can increase your memory by drinking tea. It is written here that caffeine detoxifies the liver and cleanses the colon when taken as enema. It can stimulate the hair growth in both man and woman. It relieves the post-workout muscle pain by up to 48%. It can ease the depression by increasing dopamine level in your brain, and we all know that the caffeine is an excellent CNS stimulant. So, these are the uses or utilization of caffeine. You can you are familiar with the caffeine. It's an excellent stimulant, and we consume it daily. So, this is all about caffeine. In our next thank you so much. In our next slide, we will cover our next topic, which is diosgenin. In our next class, we will cover the topic diosgenin. Thank you so much.